Okay, so the sessions, the lecture sessions, the lecture parts will be recorded. The lab sessions and the more practical part will not be recorded, right? So it's a little bit of a compromise. I want the the practical part to be more interactive and more Q&A, such that people don't feel restrained by asking stupid questions because everything is recorded, right? So we will do the second part kind of not recording and the first part with recording. All right. Any questions so far? Cool. So I tend to go really fast. I'm always carried away. So you have to tell me if it's too fast or if you have questions, right? So just raise your hand and say, yeah, wait a minute, let's go over that again, okay? So if something is a bit too fast, then let me know. So programming languages, So say in the Mentimeter, what programming languages you know so far. Yeah, I also have some opinions which you don't have to agree with. And one of the opinions I have is that Python is not a programming language. It's a scripting language. But, you may say, oh, come on, Mariusz, you're nitpicking, it is like a fully fledged programming language. It's like, no, it's not. All right, sounds good. So, yeah, that's probably Python. Yeah, if we do the brackets. So the first program we do in a programming language is like print hello world. So can you do that in all of those languages? And in which languages you can do that in? We have some Haskell people in the group. That's great. JavaScript and Python are quite strong. And obviously the courses you had so far. So we kind of building on top of what you know. And as Tom was explaining yesterday, actually he was explaining it to the second semester students. You were not there, sorry. So he was explaining that we kind of building up some of the material on kind of aerial courses such that the second semester students know where all of this is heading, right? So he was talking about C and C++, preparing you to take AlgMet and then preparing you to advanced programming and then doing some more work with cloud computing or mobile programming later on and so on. Yeah, it looks pretty good. So then there is this dining philosophers problem. Who knows that problem? Did you have it in the operating systems? Yeah. So you all should know it, right? Who didn't take operating systems? Yeah. Why you didn't take operating systems? All right, so you're exchange students. All right, fine. So that no problem. Usually the operating systems in here is a compulsory course, and everybody kind of needs to take it. So for those of you who don't know, it's a kind of a standard hello world problem for concurrency, where you have a round table of philosophers, and they either think and meditate, or they become hungry and they want to eat. But when they want to eat, they have to grab two forks on both sides. If they cannot, they have to wait, right? And as you can see, the number of forks is kind of the same as the number of people. So not everybody can eat at the same time. So some people will have to wait for both left and right fork being ready, right? Being kind of not occupied. So when a philosopher is kind of hungry and one of the forks is available, he may grab it or she may grab it, but then wait for the other one, right? And then we have a situation of a kind of deadlock, because if everybody's holding one fork, nobody can eat ever, right? And then if you are too slow grabbing one fork and then the second one, you may never get two forks, so you may starve. So you have the problem of starvation. So this very kind of abstract problem demonstrates some properties of concurrent systems, and we usually use it as an example for concurrency, for doing something where you have to get a lock on shared resource, and two threads have to fight who gets the lock on that resource. And in this particular case, you have kind of a two mutual resources on both sides, which are two threads are trying to get access to, right? So in what languages can you write that problem in? So if I told you, write a simple application of dining philosophers, in which language would you be able to do that? Yep. So C stands strong because as we've noticed before, most students took the operating system course, and most students have that problem described in terms of threads and C language, and that's where the bump in C kind of comes from. So we can see kind of this being sort of on the strong side, and then everything else is kind of much weaker to what it was for this one, right? It's not the same. And there are multiple reasons for that. One reason is that both JavaScript and Python tend to be single-threaded, and you have really hard time doing kind of multi-threaded programming with those languages, right? You can do some asynchronous programming with Node.js, but doing multi-threading here is like, it's a bit awkward. Like they are not kind of designed for that particular task. The task is reasonable to be solved in C, right? So then what is the best language to solve the dining philosophers in? If you were to choose the best tool for the job, what language would you do that in? There are some good guesses. So, so I'm trying to kind of use this lecture to tell you a little bit more about the course, why we have this course, right? You may say, yeah, this is a course about learning Haskell and Rust. And that would be partially true, but not really true, because this course is not about you learning Haskell and Rust. So this course is about a little bit something else. We're using Rust and Haskell to learn it, but it's a little bit different to learning a new two programming languages, right? So in the first slide, it says transition course. Like, okay, what we are transitioning from to what, right? The transition is that from being kind of a person who has a certain amount of understanding of what programming is, you're becoming a person which is sort of leveled up. You kind of understand programming from a completely different perspective. It's a little bit difficult and a little bit hand wavy, but bear with me, right? So what is the best language for dining philosophers? None of you knew, right? So none of you knows what is the best language to write dining philosophers in. And objectively speaking, the best language to write the dining philosophers in is the one which will come a little bit later. I have the slides not in the order I thought I have them. So so far, when you've learned C and C++, and when you've learned to solve different problems, and the problem in this case is like building a bridge. So you got a river, or you got a kind of a lake or something, you have a body of water, and you have to build a bridge, right? So you've learned tools, and you are very familiar in building wooden bridges, right? So if I give you a river to cross, you will say, yeah, Mariusz, no problem, I can build you a wooden bridge, right? And some of the bridges kind of work fine. Some of them are kind of a bit shady, right? But they still work. And that's what the skills you have. You have kind of a good, solid skills of building wooden bridges, right? But crossing a river is not only about building wooden bridges. Sometimes you want to have a concrete bridge, a really big one, right? A very solid one. And sometimes you are combining kind of a steel, wood, metal, everything together to have a construction which is sort of needed, right? So what we're trying to kind of get, we're trying to go out of what we already know and try to touch on things that we don't know yet, but might become useful later as a profession. So when you're solving problems, you should not be limited to what you know, but you should know what everything is out there and what you can use, right? So C and C++ are great, but they are not they are somewhat limited in the expressiveness and in the way you're solving problems. So objectively speaking, and it's not my kind of a personal opinion, it's like more of an objectively speaking, what is the best tool for the job? The best language for the dining philosopher is Erlang. Because this language was designed to solve dining philosopher's problem in the first place, in the most efficient and most expressive way, right? So people who are designing Erlang, they took dining philosopher's problem and they say, okay, what language and how we can construct it such that the solution for dining philosophers is the best, is the nicest, is the most maintainable, and so on. And why they had this? Because Erlang has been originally designed for telecommunication systems and for communication kind of exchanges, right? So when you have a telephony network and people are making calls, there is an exchange which kind of connects who is talking to whom, and there is a lot of concurrency going on, and that system cannot fail, and that system cannot have deadlocks, that system cannot have starvation, and so on and so forth. So they designed this language, right? So what we are doing in this course is kind of trying to expand what this language might be like, even if you don't know this language, such that it is much better to what you are suggesting, right? Because we sort of leveling up, we're going kind of a little bit more to what we already know. So that brings us to this question. What do programmers use every day, right? What is the biggest tool you as a programmer will use every day in your career? Yeah. Brain. Yes, that's a spoiler. So it's us. It's how we think. That's what is the biggest tool, right? It's everything else is secondary. Everything else is a help, but the biggest muscle, the biggest kind of resource that you have for solving problems is you. It's kind of what you have, what machinery you have in your head. And that's what we're trying to kind of accomplish in this course. We're trying to expand what machinery you already have to the machinery that is a little bit going beyond, right? So then the final thing is programming versus coding. So both of those terms are often used interchangeably, and people kind of use them as if they mean the same thing, but it's not really true. So if you were, yeah, let's see. So are those terms really synonymous? Can we use them, exchange one for the other? No, yep, we cannot. So I will kind of zoom through those two questions. We will not respond to that. If we have a problem, And I cannot draw on the board. So like I will wave my hand. So if we have a problem and we're solving it to a solution, we're doing programming. And once we have the solution and we kind of explaining that solution to someone else, that's where the coding happens. So we're coding a solution from our internal representation to something that can be communicated, right? So if I have a puzzle in my hands and I'm kind of solving the puzzle and I solved it, that means I'm doing programming. But then once I solved it and I know how to solve it, and I'm giving that puzzle to one of you, and I'm explaining how to solve it, I'm doing the coding, right? So coding is kind of expressing a solution in a particular way, in a particular structure way through a language, right? Programming is much more abstract. It's much more language independent. So coding is always related to a particular language because you have to express it. So if I have an idea in my head, if I have a problem and then I have an idea in my head, I have to choose, will I express it in English or will I express it in Norwegian or will I express it using a metaphor? Like what will I use to express it, right? I'm doing coding, but solving the problem in the first place has nothing to do with coding because there is no real kind of a choice. I didn't choose it to do it in English or in Norwegian. I was just solving a kind of a puzzle or something, right? So the distinction is quite big. It's kind of a big deal, right? But you can say, Mariusz, but how about I'm trying to do something in JavaScript and then I don't know how to do it and it becomes a problem and then I'm kind of solving it, right? So what I'm doing coding or programming, right? I'm already working with JavaScript, right? So then you will find it in some fora that what people usually say is it's a skill problem. It's not a problem that you're solving, it's the lack of your skill that becomes a problem that you have to solve because you just don't know how to do it in JavaScript, right? So it's kind of a little bit of a funny, nuanced thing that sometimes the problem that we think is a problem turns out to be a skill problem, not really a problem, right? Which is really difficult to admit because our ego usually say, come on, that's, yeah, or whatever, right? All right, so one more thing. So what is your C11? How would you judge your all right, so this question is, it has kind of a second meaning, right? Because the second meaning is in kind of in the follow-up question. So the follow-up question is, "30 players. Let's do it." So C11 has introduced the following to the language: atomics, multi-threading and atomics, collections, garbage collector, or generics. Right. So so this question is about self-reflection, right? So being able to judge what you can do and where you are kind of in the hierarchy of things, right? What is my skills? Like what are my skills? Like how good I am in C11. And this question is kind of like a verification saying, okay, if you are kind of if you know what C11 features are, what C11 features were introduced, then you should have no problem answering that. But if you didn't really work with C11, then you may have kind of difficulty, right? And this one is quite subjective. And this one is, yeah, also a little bit subjective because the choice of particular feature is kind of, maybe you are really good in C11, you just didn't thought about it, right? This particular way. But what we're trying to do is we're trying to make the matching of how we judge a problem or how we judge a solution to be as close to the objective kind of understanding as possible, right? So we're trying to avoid having solutions which kind of opinionated or very subjective. We're trying to make things a little bit more objective. And in our profession, kind of working as a team and building code as a team is kind of a big deal. So yeah, that's the message I was kind of trying to convey here, right? So some people are doing really well and some people are doing okay. So what programming paradigms do you know? Object-oriented, functional, um, object-oriented, imperative. Great. So when I was preparing for this lecture, I was trying to find some kind of a constructive. Okay, let me quit the full screen. I was trying to find some constructive criticism of object-oriented paradigm. And there is articles like this. There are articles like this, but all of them are kind of very opinionated. They are not very objectively sound. And I couldn't find something that, and of course I was reading kind of long posts about like, this is from Dijkstra. And I just couldn't find it. Like I couldn't find like a good argument which suggests that object orientation is not the pinnacle of our understanding how to do programming, right? But I give you kind of a little bit of a made-up argument. So object orientation kind of started about 78, and it had like a huge uptake. Like from 78, there was kind of a lot of interest and a lot of uptake, and many languages kind of took object-oriented features on board, right? So a lot of languages which happened from 78 onwards, they picked up on object-oriented features. And then some languages, very modern languages, which are considered kind of a very young and modern, including Golang, which you will learn in the cloud computing, cloud technology course, including Rust, they decided that object orientation actually is counterproductive, and they gave up on inheritance altogether. There is no inheritance in those very modern, very young languages, right? So why they did that? Why they killed a feature which is such a good one, and instead they use kind of a delegation and kind of containment, and they don't introduce like inheritance hierarchies at all. Well, the reason is that object orientation is sometimes misused and sometimes leads to problems. So we kind of need to be aware of different ways of solving problems and different ways of addressing some of the more challenging and more complex domains, right? So I don't like, I'm not anti-object orientation. I think every tool has a domain where it really shines, but there are very different tools. And being constrained to one tool, trying to solve everything through a single tool, it's a bad idea, right? It's the same with functional. Functional programming is not a tool to be used everywhere. In some domains, it's very painful to use functional programming. But in some domains, it's the best tool for the job, right? So then let's very briefly talk a little bit about terminology in programming languages. So this course, I'm not trying to go over all the terms that we're gonna learn in this course, but we will learn in this course some terms that have a very precise meaning, and then we can use them in discussions, right? So scripting versus programming, statically typed versus dynamically typed languages, with or without type inference, declarative versus imperative, compiled versus interpreted versus bytecode compiled, just-in-time compiled versus compiled ahead of time, rich versus limited standard libraries. So one example, which is a really good point in this one, is Golang is a language with a very rich standard library. You almost don't need to use any dependencies at all to build most of the stuff that you need to build. You just have it in the language standard libraries. Rust, on the other hand, made a choice for being very small, and almost everything you want to build, you need to use some crates. You need to use some additional libraries for, right? Lazy languages, with or without memory safety, and with or without garbage collector, right? All of those are kind of important. And all of them make a language or make the coding what it is, right? Then we have things like you should know from OO, encapsulation, types, objects versus instances, classes, pointers versus references, variables, mutable, immutable, constants, literals, functions versus methods or procedures, pure functions, side effects, concurrency versus parallelism, right? Most of those you probably know. Some of them you probably know wrong. And some of them you probably heard about, but you don't know exactly what it is. So this course is like trying to clarify and make sure that we are all on the same page. Like if someone says one of those words, it means the same thing for everybody, right? And then we have some harder concepts. We have concepts of classes, traits, and meta classes. You didn't have that in OO. Very important topic. Inheritance, I already talked a little bit about it, and generics. Some of those topics are easy. They are very straightforward. Some like you can spend a PhD on, right? This one, you can study for years and still be confused, right? Okay, simple ones, arithmetic operations. You may think, yeah, you know, that's super simple. Like we just have numbers and then we have arithmetic operations on them. But there is, again, some nuance. Like you may have operations which are overloaded, or maybe you have things that precedence is kind of counterintuitive. Logic operations, control flow. Control flow is quite interesting as well. We will spend a lot of time talking about it. So I had a chat with another lecturer about proper object-oriented languages, because C++ in some circles is not considered really object-oriented. It's like object-oriented like, but the proper object-oriented languages like Scheme, Squeak, or Smalltalk, they don't have control flow operations such that we have like in C++, for example, where we say, if this is true, do this, else do this. We have kind of a if statement, which is kind of a control flow, which splits the control into two paths, right? So in Smalltalk, you don't have if statement. What you have is a Boolean object, and the Boolean object takes messages. And one of the messages is that it is true, and the other message is that it is false. So it has a certain state, and when it is sent a message, based on the state of this Boolean object, it will kind of do either the true or false branch. So it kind of feels like a control flow, but there is, like in the language, there is nothing different to sending any type of message to any other type of object. And it just, in this case, it's a Boolean object. And in this case, the flow forks, right? So it's quite interesting. We will not dive into that because we will run out of time. But it is kind of again quite an interesting situation in object-oriented language, for example, such as Smalltalk. And then we will bang you a lot what is an expression and what is a statement. And at the end of the course, I hope you will appreciate that languages which treat everything as an expression versus languages that have a lot of statements are much more powerful and much better. So, yep, polymorphism and polymorphic types. You already know it a little bit from C++, but we will kind of go over all those topics throughout the course. And we will use Haskell and we will use Rust, but the course is mostly about this, about the concepts, not about the languages themselves. But we do have to use languages, right? So Golang is one of the languages you will learn this semester. We will use some examples in this course, but most of the work with Golang will happen in cloud. It's kind of a contemporary C. It has been designed to be very easy to learn and very easy to maintain. And literally, once you know C++ and C, you can learn Golang like in a day. You just run through the tutorial, which is online, and you pretty much know the language. You will need a little bit more time to learn all the library functions and all the support that you have outside of the core language, but the language is extremely simple. It's also very easy to use because it's very simple, but when you're using it, you will realize it's a little bit tedious. I have to do this if statements kind of everywhere. I have to check for errors everywhere manually. So it is kind of from the ergonomic point of view, it's a little bit tedious, right? It has fantastic support for networking applications, and that's where it shines, and that's where it's used most. And it's pretty good for concurrency as well. And Docker is written in Golang, so it plays really well with Docker natively. And like the build system is incredible. So if you ever had to build like a large project in C++ or in any other language, you always know this kind of this waiting, like you start building it and then you wait. With Golang, this, it really builds super fast. And that was one of the specification requirements for the language to be really fast in build times. Okay, so how about Rust? So Rust is sort of the new incarnation of C++. So it fits the same niche. So it's a memory manually managed language where you have to manage your memory yourself. And it is considered to be like a safer alternative to C++. Some people debate this. They say, no, it's like with proper tooling, C++ gives you the same kind of amount of assertions and security. And some people say, no, not really, because here the compiler is the kind of a guard. So you cannot pass the compiler if you're doing something dodgy, right? But then again, people say, yeah, but you can still do something dodgy if you mark your code unsafe. But then other people say, yeah, but you mark your code unsafe, right? So in C++ you don't have it. So yeah, it's kind of a debate, right? But it is kind of a modern language, and it has some things which are better than C++. One of the better things than C++ is that it is very well tooled from out of the box, right? So it has like all the tooling that you expect from a modern language is already there, right? You don't need to get it like extra. So it feels really modern. It's extremely small. So as I said before, in terms of languages which have very tiny standard libraries, that one is like exceptionally small. It's really good for mobile and embedded systems, on par with C. So it's very expressive. It's almost as expressive as Haskell, but not quite. But it's very up there. So in terms of how much you can express in the language, it's quite out compared to other languages. And it is quite good for cross-platform development. It's quite heavily used for blockchain applications as well, for the smart contract languages, which require kind of a cross-platform support, embedded systems, and so on. It becomes a popular choice for some of the projects. And then Haskell. It's very strongly focused on fundamentals. So it's an academic language which came from academics thinking about programming. And a lot of languages got inspiration from Haskell to include features from Haskell in their languages. And one of the examples is Rust. So Rust borrowed a lot of ideas and a lot of features from Haskell into itself, right? So it is like a grandfather of many languages, right? So if you hear about a new cool frameworks in JavaScript, the Haskell people say, yeah, we've done that 30 years ago. Like it was in Haskell 30 years ago, right? So you like once you know Haskell, not many things will surprise you from modern frameworks because they've been already tried out and they've been already developed here. So even though it is a kind of an academic language, it has a very strong link to industry and to like leading languages because they borrowed most of the features from here, from Haskell. But also Haskell will challenge the way you think. It's a really weird contraption if you're coming from C and C++, right? So my recommendation would be to try not to think in C++ way, just try to understand what is Haskell way, right? How Haskell works. It will take some time. And it will make you a better programmer because it will expand your vocabulary, your mental vocabulary, and your kind of abstractions that you can use to express yourself, to express in solving problems. It's the most expressive language there is. None of the other languages come close, right? So in terms of conciseness and expressiveness, like Haskell is super out there, right? So before we do a break, yeah, so I will talk a little bit more about Haskell, but I wanted to spend just one more thought on the expressiveness. Okay, so if I ask you to write, you are giving a list of numbers, integers, and then you have to find an average of the numbers of that list, right? So your task is you have a list of numbers, array or list, doesn't matter. And then you have to find an average of all the numbers in that list. What do you need to do? So what do you have to do so we have a list of numbers, and the task is to calculate an average, right? Super easy. How you do it? You don't have to give me like an exact code, like a pseudocode, yeah?
And divide by the number of numbers.
Yeah, so we have to kind of sum the list, right? And then get the length of the list, right? And then divide the sum by the length. Correct? Cool. So how can we do this? How can we code this? How can we sum the list? Maybe a for loop, right? Or maybe there is a function, let's call it a sum function, which takes the list and gives us the sum of the elements, okay? Correct? All right, so then how can we get the length of the list? Well, usually there is something like this, right? So let's say there is a function called length, which also takes a list and gives us the length of this list. Fine. So we have now two building blocks. We have the two building blocks that we need to solve this puzzle. And then the final building block is what? Is the division, right? So the division, divide. But let's assume divide is there, right? There is already a function where you give two things, it will divide one by the other, right? So the divide is there, right? So now your task is to combine it. Oh, come on. So now how can we compose the solution based on those three building blocks? How can we do this? How would you do this? So we have one function which takes a list. We have another function which takes a list. And we have a divide operator which kind of does that, right? So can we do that? Like, can we say sum list divide by length list, right? So in theory, we can do it in one line, right? We can do it in one line with the reference to list being used twice in two different places of that composition, right? But so that's almost perfect. Can you do that in C or C++? Could you be able to solve it in one line? If you have those helper functions, you could, right? You just have to have those helper functions, right? Ready. One maybe the sum done with the loop and so on, right? So in theory, you could do this in C++, right? But it's not perfect because in itself, so if we were to define it as a function, it would be a function which takes this parameter in two places, right? So we use this term like the code smell, that the code looks good, it solves the problem, but there is something which sort of suggests like it's not perfect, like it's like, okay, it would be perfect if somehow our solution be kind of in a form where I'm kind of doing this, the sum, division, and the length, and then I pass to it a list, and it sort of does it without me needing to pass that one parameter to two things kind of inside, right? You following me? So in C++, you cannot do that. In many languages, you cannot do that because we have to pass this list to two things, to two functions, right? And then there is no way to compose it to be a single function which does those two things at the same time and kind of magically combines the solution. Like we have to literally say, do this sum first, and then do this length next with this list, and then divide that together, right? We cannot kind of create a function which does this in a like as a single function which takes one parameter, right? We can build a new function, like we can say there is a fourth function which has this as a body, right? And that fourth function takes list in one place, right? But that would cheat. That would be sort of like not what we want. We want the one-liner with those three building blocks, right? So in many languages you cannot do that. In many languages you just don't have the machinery to be able to express it, right? And then in Haskell you do this like you do that by there is a function diff, which is integer division. So it divides, the first parameter by the second one, right? So it's the same as our function here, right? And then there is an operator which says, well, let's compose a kind of a function in a box, and then we will apply that to that inside of the box after we've done with the box, right? And then what is in the box? In the box is the sum, again composed by this magical operator, apply to length, and then we finish. We don't even pass the list yet because it is a function. It is in itself a function which takes one parameter, and that one parameter is the list, and that list magically goes into length and into a sum, and then the results of the sum and of the length are divided, and we get an average, right? So we can express this very simple problem, this very simple problem of calculating an average as a one-liner where the parameter is being passed from outside. It's not part of the solution. Why it is so important? Because it is so important because once we have that function without the parameters, we can compose it with other functions to build even bigger functions. And then we have this composability. We can solve hard problems by building those small partial solutions to sub-problems and compose the final solution by combining it together, right? By not even passing the list in the first place. So this is the magic, and this is the kind of expressiveness of Haskell. And the magic comes from those operators. And to know what those operators are, we have to kind of spend a little bit of time talking about Haskell, right? To understand what is a functor and then what is an applicative, right? You probably have heard those terms, functor and applicative, in some of the JavaScript frameworks. They sort of do this. And here it's like a very verbose benefit of having certain abstraction layers that you can use to kind of express yourself. And this feels kind of like a perfect solution to calculating an average, right? There is no extra elements. There is nothing extra that we have to think about because it is just right there, right? So when I was kind of talking about Haskell being expressive, that's what I meant. I meant that it has kind of the most distilled expressiveness power of you explaining exactly what the computation is doing without dealing with extra variables or extra, information that is kind of additional, because the coding kind of restricts you from expressing directly what you want to achieve. So we will get there, but it will take a while, right? So we will get to being able to use those constructs, but we have to spend a little bit of time, starting with basics, right? So let's have a break, and then we will talk a little bit more about what Haskell is and what it sort of feels like. So how long break? 10 minutes? All right. So let's continue. I have a little bit more theory about Haskell, but it feels like I've been talking for like an hour, so let's kind of do something. What we will need for working with Haskell is we do need to have a couple of things. So we do need to have a Haskell compiler, and we do need to have kind of like a dependency management tool for working with Haskell projects. And then we need the interactive interpreter, and we need the Hugel. So let's start with Hugel. If you just say Hugel and Haskell, it will get you like on the top of the search. It will get you to hugel.haskell.org. This is kind of like a Google for Haskell. I know the name is very cheesy, but we have to live with that, right? So then you kind of I told you about the diff operator before. So here if you say diff, it kind of tells you where it is, like in the base package, and then it tells you what type it has and so on. So you can kind of get very quick help for everything that is inside the Haskell language, and all the packages and all the libraries as well, right? So length was another one which I told you. Again, it's in the base package, and it basically tells us that given something foldable, it gives us an int, right? So given like a list or a tree or something that is foldable, it will kind of fold it and count how many times it was folding it, and then gives us an int, right? So it's like for the list, it's like the length of the list, right? So Hugel is your friend. Once you start getting your head around the notation, it will be the best thing for getting documentation. GHCI is built into the Haskell Haskell runtime system. And the best way for managing Haskell is to use GHC app. GHC app is like a meta manager. So if I say GHC app on my command line interface and I say text-based UI, I get this sort of interface, and it shows me what version of Stack do I have installed, what version of language server I have installed, what version of Cabal I have installed, and which version of Haskell I have installed, right? For those three, always pick the highest, always pick the newest. And then for this one, we will have an agreement. So we will always agree for given lab or for given task, what is the version of Haskell that we're supposed to use. The latest one is not always the best because why? So the core language kind of develops and has certain versions. And then when you are doing your projects, you have a lot of dependencies which also develop, right? And what happens is the newest version of Haskell sometimes has dependencies in such a way that this tree of other dependencies is broken, and then you get packages which are compliant with the latest version and packages which are not, and then you get into sort of this dependency hell, right? So it's usually good to go low down enough such all your dependencies are working with that version, so then your project easily compiles here, right? If you have one dependency on something newer that you don't have, then you get this sort of complications. So as you can see, I'm working mostly with 9.8.2. That has been safe, relatively safe, and that's from February last year. But I will always test, and if something is kind of newer and works with the newer version, I will tell you. But otherwise, you kind of usually you have to downgrade. But with those three, always pick the latest one. So you can go and say install by pressing I. It will install it, and then you can say S, and then it will set it as the default one, and you can say U for uninstalling this one, and now I'm kind of up to scratch with the versions, right? You get this help for what the keys are kind of at the bottom. So Q is for quit. And then where to get GHC up from? You go you go haskell.org and then GHC up, and then you install GHC up by this command. It also works on Windows. How many of you are using Windows? Who is not using Windows? Yeah, kind of majority on Windows. Some people are not. For the cloud course and for this course, it's helpful not to use Windows. You can use Windows. I mean, Christopher is using Windows and he survives. If you have any Windows questions, ask Christopher. I don't, but I kind of recommend you playing with Linux a little bit, right? So if you can install like a virtual machine or something and kind of or partition your drive and try Linux, okay? So for networking things and for cloud course, Linux will be your friend and you will be working with servers a lot and with Docker. For this course, things just work kind of more out of the box. If you're on Windows, they tend to be always some problems like path problems, dependency problems, something always shows up, right? So the Windows people always struggle in this course because like for Mac people and Linux people, everything works. And for Windows people, for some reasons or another, it doesn't work, right? And then there is always some fighting. So if you want, you can make your life easier and kind of try Linux for working with this course and cloud. If you want to stick with Windows, you can stick with Windows. And we most of the time solve the problems, collaboratively. But you can install GHC app using this curl command on Windows as well. I kind of, it's kind of a funny story, right? So when I was a student, I was using Windows, and I was a student in Poland, so we didn't pay for licenses to the, whatever, right? So I had a hacked version of Windows, and I was happy using Windows, okay? And most of my fellow students were using Windows. At some point, we started using Linux. So Linux became kind of a bit of a hype. So we say, oh yeah, if you kind of want to be a little bit of a geeky, you have dual boot, and we were using Linux for some things, but then for games and most things we were using Windows. And then I went to UK to do my master's degree. And then in the first class, like we have the first class and like the first lab, And the guy comes and he says, yeah, you know, this is a computer science department. We only use Unix here. If you want to study humanities and be on Windows, go to humanities, right? So he told us, like, it's frowned upon to be on Windows if you study in computer science, right? And I was like, really? Like, kind of weird thing. But literally all our workstations, all our labs and everything didn't have Windows. Like if you wanted to do something on Windows, you have to go to like psychology, and they had labs full of Windows machines, right? It's like so weird. So, but then I kind of really got into using Linux and using Unix, and I kind of never came back, right? So if you ask me something about Windows, I will not know. I kind of, quit that part of my life. But we know that students are using Windows, and we're trying to solve things. And most of the time, I can kind of help as well, and tutors will be helping you too, right? So if you want to stick to Windows, fine. But I do recommend you give it a try, right? You try Linux or virtual machine with Linux, maybe. Anyway, so once you installed GHC app, you can get the other things installed, and then once you have this TUI thing and you installed Stack, GHC app, and Cabal and GHC, then you have all the machinery to work with Haskell, and then the best way to kind of interact with small things in Haskell is through the interactive interpreter. So you say GHCI, and what is GHC? So Glasgow Haskell Compiler, right? So it's kind of a Scottish thing, and I is interactive. So then you have like a prompt, and you can type Haskell commands, and you can type Haskell expressions and get things kind of, you can try out things, right? So I showed you before this average thing. So let's create our list. So let's make a list of 3 things. So 1 plus 2 is 3, plus 3 is 6, divided by 3 is 2, right? So average of this list, if we do integer division, should be 2, correct? Correct. So then if I say length of L, I get 3. If I say sum of L, I get 6. If I say divide 6 by 3, I get 2. So all the building blocks work, right? So now let's create a function f, which will be our division, this magical thing with sum, with the magical thing of length. So now I can ask, okay, tell me what is f, right? And it tells me, okay, f is a function which takes something which is foldable over integers and gives me an integer, right? So it kind of gives me the type specification here. And then I can call f on my list. And then I get 2, right? So we just tested that what I showed you on the previous slide actually works, and it is what it is. I can ask it, okay, what is L? And it says, well, L is a list of something which has to be a number, right? Because 1, 2, 3, they can be integers, but they can be floats. They can be kind of complex numbers. They are polymorphic in Haskell. So literals for numbers are polymorphic as well. You don't really understand everything that is going on here, which is fine. I'm just showing you that you can ask what something is by this :I, and you can interact with commands, and you can kind of do assignments, and you can do some playing around in this interactive environment, and it is very lightweight and very useful, right? And then you quit, and then if I go, let's go to projects uni, okay? And then if you want to work on something bigger, then you will say stack new, and then say a kind of a project name that you want to call it. So let's say testing Haskell, right? Or hello Haskell, let's call it hello Haskell. You can use dashes. You cannot use underscores. And you can use numbers after letters. So there are some rules of of how you can name the packages, but like letters with numbers and dash is okay. So then it creates Hello Haskell folder for you, and then you have kind of a bunch of stuff generated automatically for you, right? And then if you say stack run inside, it will download the version of Haskell that is specified in the kind of a description file. In my case, it generated the project with Haskell version 9.12.1, which I don't have. So it's now installing it. So I will stop. It's like, okay, don't do that. I would have to change the version of Haskell by modifying this LTS version. Yeah, it's becoming too much. So just accept what it kind of generates to you, okay? I will explain that later. So once you have it installed, the program that is being run is inside this lib, and it basically say some func, right? So it kind of, again, you don't need to understand, you don't need to follow fully. I will just do what is it doing, like let it finish. It will take a while, but it basically will download me Haskell. It will compile the project and it will execute it, right? So the very basics are kind of hands-off, but then when you want to modify certain things, you need to kind of intervene. The Haskell, as you can see, is like 212 megabytes. So it's gonna take a while, so I'm not gonna wait for it. But you can kind of try it out at home. So for next week, what I expect you to do is I expect you to sort of install things such that the commands that I'm showing you, like the GHCI and GHC and GHC up, they are kind of working, right? If you have that, then that's fine. That's the level we want for next week, nothing else. So you don't need to understand all those stack YAML files or anything yet. We will kind of do it in the next 2 weeks. But GHC up, install it and install the building blocks, right? Any questions? No questions so far. If you have questions, make a question in the Discord or make an issue in the issue tracker on the GitLab. All right, so those are the prerequisites. One more slide about the setup. What editor should I use? I don't care. Like it's your personal choice, right? Yep.
Think about using Windows subsystem.
Yeah, that works. So as I said, like people used that last semester, and it wasn't a disaster. 2 years ago, it was a disaster. So we kind of changed because we were relying on some GUI components and GUI dependencies. And it turned out it worked on Mac and Linux perfectly fine. On Windows, we could make it work, but it was a nightmare, right? So we kind of, we didn't use it last semester and it was okay. So last semester was fine. So you can use Windows subsystem, Linux subsystem on Windows, and it will work. Yeah. Yeah, with IDEs, you probably have your own preferences. Most of the time for very small things, I use Vim and VI and NeoVim. So I try to be kind of console based, especially if you work with servers where you don't have any other feature rich editor. Those kind of keyboard shortcuts and everything comes very handy. But if I'm working on a very big project, then I'm usually using IntelliJ, right? And you, with the NTNU email, you can get IntelliJ Ultimate license, and you can use IntelliJ Ultimate for as an IDE. It's very big. It chews up your battery if you on laptop and so on. But it is quite good, right? In terms of support and features, it's quite good. VS Code is also very good. And VS Code works really well with Rust and with Golang too. Same with the ultimate version of IntelliJ. So pick something that works for you, okay? The tutors and I may help you set up the environment the way you want it to do with Haskell if you get in trouble, but I would like you to try it on your own, right? So if you say, I would like to use VS Code, fine, and then install the plugin for Haskell and try to make it work with Haskell, okay? And then you may come to me and say, how do I do this? Or how do I debug, Golang code in VS Code? And then I tell you, no, you don't debug code in VS Code, right? You need like IntelliJ or something. But like try it out. So if you say, yeah, I don't know what to do, then try to find a tutorial and try to find how to get your IDE working with Haskell or working with Golang, okay? It is not that super easy, but you need to be able to do that kind of yourself. The same for Rust, right? So I'm using my IDEs. I'm using all three. I'm using VS Code, IntelliJ, and Vim. And I have them configured for Rust, Golang, and Haskell, and C and C++ as well. And then depending what I'm doing, I'm picking one of them. All right, so then one more thing about prerequisites and IDEs and tools is the ChatGPT, okay? So I encourage you to use ChatGPT as an assistant and as an explainer how things work and why things work the way they work, right? So from day one, you should use it for asking questions like, okay, how this symbol works. Can you give me examples? Can you give me an example in JavaScript of explaining how this works in something that I can understand, right? So do that. Last semester, a lot of students did that and they really enjoyed working with ChatGPT in terms of explaining to them how certain things work. So I encourage you to do that. I discourage you from using ChatGPT to do your work, right? So if you say, please generate to me an average of the list, right? And then it generates and you say, yeah, that looks good, copy and paste, right? Try not to do that, because if you don't type it yourself, if you don't kind of convert what you have in your head into something yourself, then in the exam, you will get kind of into trouble. So at the end of the course, we have an exam, which is without ChatGPT. Like you will be sitting in front of the computer with your brain, and that's all you have. And you have to solve things, and you have to generate small code snippets, and you have to find bugs, and you have to do things with yourself, right? And you cannot ask ChatGPT for it, right? So you try to use ChatGPT to train you, but you try not to do the work for you, because then in the exam you will kind of suffer. Like you will be like, oh yeah, what was that? Was it length or was it len, right? If you never typed it, you may kind of not remember, but if you typed it 1,000 times, you will know it's length. You typed it 1,000 times yourself. So some things will come from muscle memory, and then it's useful to kind of do things yourself. But definitely use ChatGPT to explain things to you. There will be labs where I will explicitly tell you, try to solve this lab using ChatGPT just by doing prompts, right? And don't write any code yourself, just make ChatGPT solve that problem for you, right? So last semester, what happened was I was asking students, don't use ChatGPT, and some of the students were using ChatGPT. And then I was telling students, please use ChatGPT for this. And some of the students, they say, no, I hate ChatGPT. I solved it myself, right? Both options are wrong. You try not to do that, right? So when I tell you use ChatGPT, try to use it, because the point is to learn how to do prompt engineering. The point is not to solve the problem. The problem is how to design a prompt that ChatGPT solves it for you, right? So if you never designed a prompt, then you are lacking those skills, right? So if you solved it yourself, you sort of failed, because that was not the task. The task was how to engineer the prompt, right? And then in the exam, I do have questions which says, what prompt would you use to solve this, right? And then student wrote me, I never used ChatGPT, so I'm skipping that question. It's like, no, you have to answer that question, right? So it's part of the course. So we have this kind of love and hate relationship with ChatGPT. Like some people totally hate it. Some people like, oh yeah, it's brilliant. It solves everything I need. Yeah, try to find the balance. Like sometimes it's useful, and sometimes like for generating certain things, you just like it's a boilerplate code. Like, why should I be typing that, right? Let it generate it for you, right? But sometimes, you do need to type small, simple things. So my advice would be for initial, all simple things, try to do it yourself. Try to kind of do it yourself. If you can't, ask for help. ask ChatGPT for help, but try to kind of do it yourself. For more complex things, we'll be more and more heavily using ChatGPT, right? So there will be some tasks, some labs that if you want to do everything yourself manually, it will be quite a lot of work. But if you can use ChatGPT to help you, it will be quite manageable amount of work. So then I will tell you, use ChatGPT because I want the task to be kind of manageable. And the point is to balance this kind of a prompt engineering with finding the proper solutions, right? Any questions about that? So we don't have an assignments in this course. We run like a small tasks, small labs, and you will show what you have to the tutors or to me, and we will take you off. You don't have to say, oh yeah, this is what ChatGPT did, or this is what I did. I kind of don't care. As long as you understand what the code is doing and how the code works, I don't care who wrote the code, right? So you don't have to say, yeah, that part is copied and pasted from Stack Overflow, that part I took from ChatGPT, and that part I kind of wrote myself, right? I don't care. As long as you understand everything and how everything works, that's fine. In the exam, you will not have Stack Overflow and you will not have ChatGPT. So some things you kind of just need to know how to do, right? In the cloud course and in some other courses, it's very important that you attribute stuff that you didn't do yourself. And it will come even more pronounced later in some of the courses where you have to write a report or write like a project. You have to say, okay, that function or that piece of code was taken from Stack Overflow, or that piece of code I got from this prompt from ChatGPT and so on. You have to attribute where the stuff comes from, right? In this course, it's very exception that we we kind of put it under the carpet. Like we kind of pretend that we don't care, right? So like normally it's very important that you don't plagiarize and that you attribute where stuff comes from because somebody is grading your project, right? In this course, because you have to talk with the tutors and the tutors will ask you questions, and if you don't know the answer to the question, you will not get the tick. We don't need this attribution, like because it's interactive. It's like human to human, okay? When you create something written and that written thing is checked and you are graded on what's written, being able to tell what comes from where and being like putting the attribution is super important. Because if you don't do that, then you can be, called out on plagiarism and like not attributing and things like that, right? It's a serious problem, right? So don't treat this course as a sort of a template. It's not, it's an exception. The rule is you have to attribute. Every time you're taking code from Stack Overflow, you have to remember what link was it, and you have to put that link in your documentation. Every time you're doing something with ChatGPT and copying from ChatGPT, you have to say, this is copied from ChatGPT and so on. So in this course, it's an exception, but with all the other courses, you have to do proper attribution, right? Is it clear? All right, sweet. All right, how are we doing with time? Yeah, not so great as always. I talk too much. So Haskell, functional, what does it mean? Functional means the main kind of concept in the language are functions, right? Oh, you say C has functions, C++ has functions, so what's such a big deal? Yeah, you will see, right? We do functions for things that you normally don't use functions for, right? Like, for example, keeping state. What do you do for keeping state in C and C++? Well, you use a variable, right? Guess what? We technically don't use much variables in Haskell. We kind of keeping state through functions. Like, whoa. All right, pure and lazy. Pure means when a function is given input, it produces output. And a pure function for the same input always produces the same output, right? That's what means to have a pure function, right? So if the function takes some input and always produces the same output for that input, it's a pure function. If the function takes input and depending on some state, additional state produces different output for the same input, it's impure, right? So with objects, usually what we have an object. The object has some state. We have methods which take some parameters, but then based on those parameters, the behavior or the output might be different depending on the state of the object, right? So most functions or most methods in object-oriented programming are not pure because they depend on the state of the object, right? In Haskell, we don't have that. We always have pure functions which depend on the input, and that's it, right? You can say, yeah, that's kind of fine. So if I do this, right? So let's say I have some class C or object of class C, and then I call a method on it, right? And the method takes parameter 2, right? And then depending on the state, I can get some different values. I'm getting kind of different values. So you say, yeah, I got what you say. So how about if I have a method M, which takes my object and 2, and always produces the same thing based on the state of O, right? So depending on what the state of O is, plus 2, it produces the same output. Would that be a pure function or pure method? Yes, it would be, right? So given the same state of O and state of 2, which is 2, always produces the same thing, that it's a pure function because it doesn't depend on anything outside of that parameter list, right? If that function doesn't check any global variables or anything, then it's a pure function, right? Pure method. Then it's fine. So can you have pure functions in object-oriented programming? You can. What lazy means? Lazy means that when I have an expression and I'm evaluating something, I don't do things until I really have to do them, right? So in imperative programming, if I say m equals 2 plus 2, and then I'm doing like b equals something, and I'm calling m or function fun, and so on. When this expression is gonna get evaluated? Well, it kind of gets evaluated in C the moment my program kind of hits that line and this assignment happens, right? So this assignment happens and that expression gets evaluated. In lazy programs, nothing happens, right? So nothing happens to M, nothing happens to that expression until I sort of say, print me M. Then in this line, it says, okay, I need M. Where M comes from? Okay, M comes from this assignment. And then the right-hand side is this expression. So then it evaluates that expression, right? In the kind of last minute, like when it actually needs it, right? So in Haskell, when you prepare something, so let's say you're generating a list. So you're solving something and you're generating a list. And then you're not using that list never get generated. Like the system will do nothing until you say, okay, from this generated list, give me the first element. That they will only do a list with this first element. It will not do the rest, right? So in lazy programming, what it means is we can do things like dealing with infinity. So I can say, I have a list from 1 to infinity, and then it's fine in Haskell because it's lazy. Like you cannot say in C, I have a list from 1 to infinity because like that would require infinite amount of memory and that you don't have, right? But here you can do that. Like you can say, yep, I have a list from 1 to infinity, and then I'm adding 2 to all those elements from 1 plus 2, 2 plus 2, 3 plus 2, all the way to the infinity. And then, you know, nothing will happen until you say, give me the 10th element. And then it will do it until the 10th element and give you a 10th element, right? So lazy is quite an interesting concept. Okay, it's very concise. You've seen it. It's a little bit academic. So there are some commercial projects using Haskell, and it has its uses in the industry. Even Facebook is using it, but it's not as widespread as other languages, right? And it is difficult. So once you kind of master Haskell, I don't think any programming language will scare you, right? So like once you sort of familiar with Haskell and kind of move around Haskell, then it will be kind of like all the other programming languages will suddenly become kind of either tedious or kind of not interesting or easy, right? It doesn't mean that they don't have a lot of details, right? For example, C++ has a lot of intricate kind of details about memory management, which is super like geeky and super important. And I don't know all those kind of details like with the memory consistency, right? And it's very difficult. It's much harder than some of the concepts in Haskell. So this kind of difficult may be a wrong word. It's not, the difficulty not comes from the details. The difficulty comes from the conceptual understanding how the type system works and how function works, right? So some things will take kind of a long time to click, to understand what it means or how it works. It doesn't mean that you cannot use it earlier, but you know, some things are a little bit slow. All right. So then we have a question. Oops, sorry. This one. So we have 5 more minutes. All right, so we have a couple of questions. So 3 languages, Haskell, Rust, and Go. Interpreted, compiled, or mix? Good. Or compiled? Another question. 3 languages. All dynamic, all strictly typed, or some strictly typed and some dynamic? What does it mean that the language is strictly typed? If the language has a variable, the type of that variable cannot change. So once the variable type, let's say, is int, for that variable, it will be int to the end of the program. For dynamic languages, like Python, you can say, yeah, my variable m is like a string, and then you say, no, actually it's a, it's a different type. It's like an int, right? So the type can dynamically change back and forth. In strictly typed, once the type is established, that's it. In Rust, it's a little bit nuanced because in Rust, the variable can go out of scope. And once the variable is out of scope, there can be a second variable with the same name, which has a different type, right? So it kind of pretends that it has dynamic feature, but it doesn't. Like the variable always have one type, which is assigned to that variable. All right, one more. Again, 3 languages. So language with type inference or no inference, and some with and some without. What is type inference? Type inference is where the compiler and the language can work out what the type of something is without you telling it, right? So if you say, like you have it, like, did you use auto in C++? Yeah, so it's like this, right? So if the language can work out what the type is without you telling it, you're saying it's auto, I don't know what it is, just work it out. That means the language has type inference, right? If you have to tell the type, that it means the language doesn't have type inference. So all 3 have type inference, right? All right. So we have 3 languages this semester, all strictly compiled, strictly typed, and with type inference. Why do you think is the case? There are many other languages which have those properties, but what is the distinguishing feature? Yeah, good arguments. And programming, not scripting. Yes, I can see some people did their homework. So for large projects, large programming projects, it was sort of evolutionary decided that compiled, strictly typed, and languages with type inference are superior to everything else. They are kind of easier to maintain. They are easier to control what is happening with the projects and so on and so forth. So you working in your career with large software projects, which you will be as a software professional, I'm very likely to be exposed to this type of languages, right? Okay, we have two more quick questions. Okay, so this one is about type inference in C and C++. So both have type inference, both do not have. C++ exists has, or C has. Very nice. So pretty good. Some people were paying attention. All right. Yeah, kind of a very even game. Nice, Frosty leading the pack. So final slide. There is no group projects in this course. Everything is individual, which doesn't mean you should not work as a group, right? I do encourage you to work with your friends and as a group. But then when you are talking with TA or me to get your labs sorted, it's one-on-one, right? So it's what you know, how you understand it. So there is a balance. We will be doing a little bit of theories. This session was 100% theory, but we will be kind of trying to balance hands-on and theoretical discussions. And then the practice is very important. So you do need to practice. You do need to try things out, play with the GHCI, and kind of not only watch tutorials and not only like read books, but you need to try things out, like literally. I have can you get fit from watching fitness videos? No, you cannot, right? It's the same here. You can watch as many tutorials as you want and read as many books as you want, but you will not learn how things work until you try it out yourself, right? I often have an idea and I kind of feel that I know how it will work, but you still need to try it out. Like you kind of need to verify. So yeah, practice. Yep, that's it. Any questions? So thank you and apologies for keeping you 2 minutes over time. It's